Hello, my name is Ingrid Hotz. I'm working at the Division of Media Information Technology at Linköping University, and I have the pleasure today to tell you a little bit about my research, how we are taking data and try to make the best out of it. So data is one of the most valuable resources that we have nowadays, which has been framed by The Economist 2017 as data is the new oil. And it's certainly true that there are a lot of new opportunities coming up through data. But on the other hand side, data is also one of the biggest challenges that we have to deal with today. So data impacts basically our life everywhere, in society and also in research. It starts with healthcare, where people are exploiting sensor data, for example, from your phone that you're carrying around and constantly tracking your activities. This is personalized medicine, where we try to find the best treatment for a person using data, screening data, imaging data. So this is this case in climate science, where we try to predict the future outcomes of the actions that we perform today. Or as a last example, I have the development of more sustainable materials, which also relies on large scale simulations. So in general, when you are starting to collect data or to generate data, you have some questions in mind and start the process, and the result will be a lot of data. But the goal in the end is to get some insights, to find some solutions, or to make a decision in the end. And to a certain extent, you can interpret this process as a way of a data reduction, where you start with really an overwhelming amount of data and try to find your answers, which in the end might be only a very small amount of data. But on the way there are a lot of steps happening which require novel solutions and research. This starts with data handling, like data storage is a big issue nowadays. It's about data quality, integrity, security. And last but not least, it's about data analysis. And there we have a lot of automatic methods using machine learning, but you also can have the human in the loop doing some using visualization to understand the data better. And this is a part of my research, and I will talk a little bit more about that in the following. Sometimes we call this also visual analytics, and this can be defined as a science which helps you to reason about your data by providing support from automatic methods through visual interfaces. Typical questions that we are concerned with is to ask, so how can we use the data in the most efficient way? How can we find something interesting in the data? If you, for example, look at this image here, you see it's a simple data set, so a box with flow data, where we just threw in a bunch of glowing particles, and their traces are displayed here. Even so, this image basically represents the entire data set. It's not really helpful at this point. Here's a question: how can we find the interesting? In this case, this would be the swirling motion in this data set. And in the bottom image that you see here now, this has been automatically extracted using topological method. And now we only show these particle traces that are really relevant to convey this information. Tracking changes is very important in this context, also comparison of large amount of data. All these questions can only be answered in detail in an application context. However, in the background, there are a lot of concepts that are applicable to many different scenarios. So in my own research, I'm mostly confronted with data that comes from some scientific applications. Now I picked a couple of examples to show you how this can look like. So the first example comes from a molecular dynamics simulation. Such simulations are interested in different contexts. Here, the context is the development of novel drugs. And it's very important to understand the docking process of these little ligands that you see here with a larger molecule. Such a data set consists of thousands of time steps, and you can stand here and watch this movie and hope that something interesting happens. However, something much more efficient is to provide an interface that does some analysis for you and supports you in finding the interesting in the data. Here, for example, the chemists are interested in investigating certain angles within their molecules, and they can put in this query to the data set, and automatically the answer is directly extracted from the data set and displayed in these timelines that you see on the bottom here. And this allows you to really jump to places that are of interest to you. So the second example here is an example from material science. It's a design of organic solar cells. These are solar cells which are very flexible and have a lot of applications. However, they are not yet as efficient as the solar cells that we know otherwise. Organic solar cells consist of two materials which have a very complex morphology, as you can see in this image here. And an important investigation now is how the charges move through this topology. And here these are physicists, are running Monte Carlo simulations to get some information about the charge movement in this material. They're here displayed as green and red trajectories. However, again, this picture by itself is not so much helpful. But if you are having a closer look to the material and the morphology, we can basically boil everything down to a charge flow network. And in the end, we can get a very abstract representation of our data, which can easily be explored while always keeping the link to our original data. And you can always go back to the geometry and see what you are currently exploring. So the next example is an example from a medical application where the goal is to understand the disease, where you have symptoms in your head and you have symptoms in your gut, and people would like to know how this, what are the reasons for this sickness, where does it come from? And here we have a lot of different data. So we have many patients that have been filling out questionnaires, giving some information, for example, about anxiety. There are a lot of measurements, for example, of blood. And there are also screenings of the brain, of the function of the brain in a resting state. And now the question is, are there any correlations between all these measures? So what you see here on the bottom is something that we call parallel coordinates, where every of these bars represents one different parameter, and every line in these coordinates represents one patient. And now the medical doctor can go there and put groups together by filtering out certain properties, combining them together, can put complicated queries to the data set, getting an immediately feedback about different correlations to the activities in the brain. An interesting fact is that many of these methods that we originally developed for the scientists, for the exploration of that data, can be used in a similar way for science communication. So the image that you see on this picture here is taken in the visualization center in Norrköping, and it's displaying an exhibit about the blood flow in the heart. So this application has originally been developed for the scientists to compare the blood flow, for example, from a sick person and a healthy person, from a young and an old person, or here in this case, also looking at an athletic heart. But in many cases, just with a little bit simplified interfaces, this is also very interesting for the general public to get an understanding of what's happening in research. So now I've been talking about a couple of applications. However, there happens a lot in the background to get these applications going. And in most cases, the first step is to find something that we call feature descriptors that provide a descriptive summary of the data targeting your needs. And the second step would be kind of to develop some metrics to compare these features, which allow us to track something over time and detect some changes. What you see here in this image is again a simple data set, a flow data set, where now the lines that you see are tracking of vortices over time. One of these tracks is highlighted here, and again you can get an abstract visualization here which can then be explored in more detail, where we show a lot of statistics that had been aggregated along these lines. Similarly, you use feature descriptors and metrics to explore large sets of data, or some ensemble data. Here in this example, so you see a molecule where people are interested in a charge transfer when you excite this molecule, but not only for one molecule, but for many. And here, finding a simple descriptor for this process helps to understand people in one view what is happening here, but can also be used from the machine to use, for example, clustering methods to get an overview over your entire data set. So in summary, as I tried to give you a little bit insight into what visual analytics does, with a goal kind of to transform numbers, to transform data somehow into insight. So this work is always done in close collaboration with the domain scientists who are generating this data. And it's combining automatic analysis methods with interfaces that support the human in data exploration. Very important requirements for all methods that we are developing here is to be transparent, meaning we want to communicate what we are doing with the data so that the user really knows what's happening here. Methods should be reliable and robust and also be able to work if the data is a little bit corrupted or something is missing. And the results should be interpretable and targeting the scientist's needs. Thank you for listening.
Thank you, Ingrid, for that presentation. Very visual, and that's the theme, I believe, here.
Yes, exactly. So you got it.
Yes, I got it. And I think, it's always nice to see, that kind of presentations. You really get mesmerized, and I understand really. And I'm thinking, we talk about big data. Is it necessary to have this kind of presentation? Otherwise, we won't ever be able to get the core of big data. If we can't visualize it like you're...
Yeah, for sure. There are many methods to automatically extract also some information of data. But something that I also wanted to mention here. So big data is the question, what is big data? I would say big data can also be not so huge. It's always big if your standard methods are not capable to deal with it anymore. So this can have very different ranges.
Yeah. Because when you're doing your job, you don't feel it, not that big. I can understand it. Yeah. So just tell me, how did you get into this area? Well, is it your dream as a girl in Germany, I believe?
No, this is actually a very, very long story. So
tell me.
So my background is in physics.
Okay.
And I did my master's in physics.
Where?
In Munich, in Germany, yeah. And this was very much just pen and paper. And I thought about, there are only kind of 5 to 10 people in the world that can talk about my research.
Okay.
And I was missing a little bit the communication and interaction with people. And then it rather happened by accident that I ended up in visualization. I saw a poster announcing a workshop about visualization, and I just applied there. And immediately after I had to give a talk over some papers. Immediately after that, the professor offered me a PhD position, and I said, okay, yes, I do it.
Okay.
Yeah, and now I think probably I'm even doing more physics sometimes than before, so I can approach things on a very high level. I have the opportunity to talk to so many different experts, which are really doing top-notch research here and there, and I'm allowed to ask all the stupid questions.
Well,
because I also have to understand. I have to also to understand a little bit to develop methods to support them in the data analysis.
Do you think it's important to have the background from a researcher perspective to be able to do the visualization?
It's definitely helpful.
Yeah.
For sure, it's a long process until you're getting in my position, and during your PhD, you have the possibility to develop knowledge here and there. But it's always important that you show some interest to the data, that you try to understand the needs, and that you really communicate with the people who are needing it. Yes.
And then from Munich, you ended up in Norrköping.
Not immediately.
No. Well, I realized they were. But,
yeah.
But and how come you came to Norrköping and you have this magnificent team there?
I think as a visualization researcher, you want to be in Norrköping. Yeah. Norrköping is really one of the centers in the world where most is happening. It's a wonderful place. We have a dome theater. We have this museum in addition. And a lot of people dealing with different aspects of visualization in one building. I think this is the perfect place to be as a visualization.
And the dome theater, tell us just about that, because I haven't been there, but I heard about it. What is that?
So I don't have the numbers in mind. So this is kind of a half sphere where we have a couple of projectors that are projecting the visualization in the dome, and you get kind of a three-dimensional immersion while watching.
Will I get car sick in it? Will I?
It can happen.
That often happens.
It can happen, but we for sure try to avoid that. So if you make
no vomiting in the dome, please.
Yeah, sometimes people get sick.
Okay.
Yeah, it can happen.
Well, I'd like to go there because it sounds fantastic. But I'm thinking here, the art of visualization. How good are we when you look around within the academia or all around? Are people if you take an overall perspective, how good are we at presenting data?
I think, so you mentioned now presenting data. Presenting data is one aspect, and analyzing data is really another aspect. Everybody uses visualization for presentation. If you go to any talk of any area, you will always have pictures on your slide. And every picture on the slide is some visualization. Sometimes you are not even aware of that. To some visualizations we are so used that we do not even think about it. But I think this is something very natural that we even have in textbooks at school. Everything is visualized to explain some concepts, to communicate some things. But also in math, if you remember, that there has been the analysis of functions where you look at peaks and valleys. So this is exactly what we are doing. This is large data also. Asking exactly the same questions that you probably know from your math class in school.
Yeah, and so do we need to get better overall to be able to get into the future and use all the tools, because it's understanding through this.
It's understanding, and I think visualization is important in almost all areas, and it's getting even more important with the increase of the amount of data. But I think it's also very important that the automatic methods and visualization are somehow combined to bring together the best of both worlds. But also, a screen only has a certain number of pixels, and we are only able to take in so much. So we have to do some simplification for it. We have to do some analysis. We have to focus on aspects of interest there.
Because we're talking about a very large amount of data sometimes, and it's complex, and we need more research further on. How do you say this is necessary for getting to asking the right questions for next level of research? Is that the key to get to the future? So understanding, okay, this is what the big data, what we are gathering. So from the understanding, we are enabled to ask the next level of questions. Do you get what I'm?
So this is actually a process. Visualization is not a picture. Visualization is not one solution. I always see this as a process in working with people. So we are providing something, they're using it, and hopefully new questions are coming back, and we are developing new methods supporting the questions that are coming up.
And I believe the researchers themselves, they don't really, they cannot really grasp the amount of information. So helping them understanding what the research is all about, being able to ask new questions.
For sure, we are dreaming of that. So sometimes you also must be a little bit careful because people know their data quite well. It's not like that I can come in from the outside and solve all their problems.
Of course you can.
Of course I can, but I'm not allowed to say it in that way. No.
Okay, yeah, great.
I just it's kind of trying to support, and this must be an interaction.
Yes. But when it comes to, I'm thinking of techniques because we're close to the world of the gaming industry. We have these big screens and we have the all kinds of games, computer games. And also we have augmented reality, virtual reality, getting into these. What are the future when it comes to, can we use that kind of techniques when it comes to visualization?
That kind of technique is used all the time.
Yeah.
I think much of the technique when it comes to graphics, to the representation of the final image, is really developed in the gaming industry. There's the money and they can do this development. This is not really our research. We are rather using these methods.
Yeah.
So most time we are really concerned with data analysis and thinking about what would be a good visual abstraction of something. And then we're using all the computer graphics that's around there. For sure, we also have to know a little bit about this to make things fast and efficient. But this is basically the last step in what we are doing.
But should we welcome more collaborations between the gaming industry and this kind of...
There is definitely some collaboration.
Because
there are interactions in any case, so yeah.
Yeah, and are the gaming industry aware of that? Are they going into this kind of, visualization of research?
I think they are probably not too much interested in what we are doing. So they have... A fundamental difference is that we are trying to take real data and make pictures out of it, and they create their own world.
Yeah.
So they have all the freedoms. They don't have to be true to some data. If they show a waterfall, it doesn't matter whether this really happens like that. It has to look somehow plausible. So, but they don't care about.
Yeah, but I mean, if you mix it, you have we have to. Keep the facts right. We cannot change even if we want, but just enable new interpretations, looking from different angles, having fun with it. Okay, we can do this. Okay, I see.
Yeah,
that's a kind of
this happens.
Okay,
certainly, yeah.
So you need to bring all the techniques from the gaming world into and first shoot a game with it.
I would say, especially the PhD students who are working in visualization, they are often also gamers.
Yeah.
And this automatically establishes kind of some link between these two worlds.
Yeah.
Yeah.
Well, it's very fascinating to see. What about where do you start? If I come with I have tons, large amount of data. Ingrid, help me, take this. I have about pedestrians in Burkina Faso. I just have data. Help me. What would you do?
The first thing that I would visit people and look what they are currently doing with their data to get an understanding what is a typical workflow.
Yeah, we have this collaboration with Burkina Faso about pedestrians and aside.
So probably I cannot go to Burkina Faso, but I would visit the researcher, and this researcher would explain me why am I doing this. These are questions, etc. What are your questions? What do you try to learn from your data?
And you talk with the researcher now.
Yeah, exactly. Yeah. I would talk with a researcher as a person who collects this data. Yeah. Because everybody who collects data has in the back of the mind some motivation. Yeah. And I think we are trying to figure out what is this motivation.
Are they good? Could it come with a situation where the researcher don't really know we don't really know actually what we are doing? We have a feeling, but we're not really.
So it's always the case. I think, and this is a fun part of our job, trying to nail people down to something more specific. Okay. And often people come with vague questions, and we have to translate this somehow into the formal. And then asking back, do you mean this? Yeah.
Now she comes again. Ingrid from Germany with all her questions.
People might, for example, say with the pedestrians, I look at the data somehow, I see some patterns. Can't you extract these patterns? And then you try to figure out what do you mean? These patterns. Yeah, I see this zigzag here, and there's a line going there, and then you try
and they have a gut feeling. Okay.
Have a gut feeling, and then you try to nail it down more and more and more, and then we look back in our toolbox, kind of our experiences that we have, and consider, oh, this might be something that could fit here, and then there are kind of first steps that we are trying to do some stuff with the data, and then
and then you show them, this is where we are at the moment. No, that's not what I'm looking at.
Yeah, but there you also must be careful, because people often do not even know what's possible. So in the beginning, people are often very reluctant if they are seeing something new, and then you are kind of the one who have to sell also your method. You have to give people time to get into it, because it provides completely new perspective onto something they have probably working with for many, many years. And all of a sudden somebody from the outside comes and says, did you look from this angle, or might this be interesting? And this is also the point where, for me, collaboration either becomes interesting, where I see there is also some interest, because there must happen something from both sides, or people are completely not willing to accept something new. And then this collaboration is not so interesting for me from a research perspective, because we are also longing for novel questions. We want to go a step further, not use the methods that have been used for a long time and that are well established.
Does it happen that you run into a conflict and no, we won't solve this. We have an idea, but the researcher won't buy it.
I feel it pretty early. So when I build up my collaborations, it's a topic that should be interesting, but it should be an open-minded person also. And you feel it very soon.
Okay.
Yeah.
Fascinating. And since we are looking into the future, and we all have to come along, what will you see in 10, 20 years ahead? What will happen in this area? What will be the future? Can you have any thoughts? Where are we going?
So I think the methods coming from machine learning and the methods coming from an analysis with a human in the loop, they will be much more integrated, hopefully. You always have to think about, where do I need the human at all? Everything that can be automized, which is just a burden for us in the analysis. So it's great if the machine comes into place and can support what we are doing. On the other hand side, I think visualization can also support a lot the understanding of what the machine is doing, to make a little bit more transparent, kind of opening this black box and saying, this is what's happening here. This is what's asking the questions also, why. But I think bringing these areas together in an efficient way and realizing this is not a competition, but this is kind of complementary, I think this is where we are heading to.
Yeah. And I'm thinking of the entertainment industry. We have this sense around, all the senses, smells and sounds and different. Will have now we talk about visualization?
Definitely. And visualization is sometimes even meant in a broader sense, so that sonification will be a part of it. We ourselves, we have a project where we use a haptic pen to follow the blood flow in the heart. So where the pen is kind of attracted to the flow, you have the visuals, but at the same time you can kind of feel the resistance of something.
Okay.
And this interplay between these different senses makes the experience of much stronger. Yeah.
Well, this is very fascinating. Well, thank you for coming here and telling us all about these astonishing things. Good luck in the future. And
thank you very much.
Send our regards to your team in Norrköping.
Definitely, I will do this. Thank you.
Thank you all for participating, and I hope you enjoyed.